Alright, here's what we're doing in section 3 is we're going to look at the properties that the integrals take on. We're still not looking at exactly how the integrals are solved out. We're just looking at how they work and some of the different properties, like the order of integration. For example, we usually want to start with our smaller number on the bottom and finish with our larger number on the top of the integral. And so if you happen to have it the other way around, we usually we're going to do something like this. Well, if you flip them and you go upside down, then you put a negative number out front. Typically, you're going to start with your small number here and your large number here. But if you go in reverse of that, then we would just put a negative in the front. So you'll see that every now and then. It's not too often, but sometimes it comes in handy to be able to just write things in a different order. The zero property is if your integral equals 0. Constant multiple. Now this is a really handy property right here. If you have a constant, you can always take the constant and move it outside the integral. This is a great rule. You will use it all the time. It is your friend. So get comfortable with that particular rule. The sum and difference rule. Pay attention to the plus and minus signs. So if I've got two functions inside here, I can integrate both by looking at the separate integrals of both. So if you're going to add them together, you've got to add your answers, and if you subtract them, you've got to subtract your answers. So pay attention to that. Additivity, if I go from a to b of a function and then from b to c of the same function, then I can look at that whole function from a to c. We'll look at an example of it. So in other words, if I have some function that goes from 0 to 1, and we don't know what that function is, but it equals 2, and then I have the same function again from 1 to 4, and again, it's just defined by f of x. They're the same function, and this is 7. Then I can look at the function from 0 to 4 of f of x, and it would equal 9. You would just add those two guys up. So that's a real handy rule. We'll use it every now and then, but it doesn't creep up just a super bunch. The maximum inequality, we're going to look at an example of this one. We don't do it a ton, but it is handy to note that if you take your minimum value, okay, your minimum value of the function, whatever your function is, whatever the minimum value of the function is, times b minus a, it should be less than the integral of your function, which would be less than the max value of your function times b minus a. And usually, when we do this, we're trying to compare it against a max or a min. So again, we don't use this just a super lot, but it's a good one to have in our back pocket if we're trying to show something. The same with domination. If your function f is greater than your function g, then your integral of f is going to be larger than your integral of g over the same interval from a to b. And again, we don't use domination too much either, but it is also a pretty nice one to have in the back pocket. So let's look at some different rules that you could get from your functions. For example, this is the one about getting the negative sign or not. We usually start at 1 and go to 4. We've got a rule for going from 1 to 4. So this function, we would just say the negative of 1 to 4 f of x dx. And what would it be? Well, it would be negative 2, which in this case would just be 2. So that's the first guy. So he's not too bad at all, and he's fairly easy to sort out. If I go from negative 1 to 4, then that's the combination one here. So I go from negative 1 to 1, and then I go from 1 to 4. And so what I can do is add those guys together. So I can take this function from negative 1 to 1 of f of x dx plus the function from 1 to 4 of f of x dx. And we know that the first guy is equal to 5 and the second guy is equal to negative 2. So my total answer is going to be 3. And that's a pretty handy deal. Whoa, let's leave him there. That's a pretty handy deal to have. So keep him around and just be aware that that's one of the tricks that we can use. So let's move this guy out of the way a little bit here. All right, over here, I've got 2 times f of x plus 3 times h of x, both going from -1 to 1. I've got a rule for both of those guys, so I'm going to use my f of x function and my h of x function. Here's the cool thing. I can pull the 2 out in front of the f of x1, and I can pull the 3 out in front of the h of x1. So it's going to look something like this. 2 from -1 to 1 of f of x dx plus 3 times -1 to 1 of h of x dx. Well, my integral from -1 to 1 is 5, so I'm going to have 2 times 5. And from -1 to 1 for h is 7, so I'm going to have 3 times 7. So this is going to give me 10 plus 21, which is 31 for that guy. And again, just kind of go at an easy pace. Make sure that you're paying attention to what you're doing. Make sure that things can add up correctly, and you'll get where you're going. Okay, from 0 to 1 for f of x, we don't really have a rule for that. And I'm looking up here, and I don't see anything that would allow me to subtract and get to anything. So on this guy down here, there's just simply not enough info to solve this one out. We would need one more property in order to solve this guy down and get into something that we could do. The same one for -2 to 2 of h of x. We don't have a definition for that. All we've got is from -1 to 1. So the same rule applies to this guy as well. Well, what about this last one? Well, we've got a rule for -1 to 4 of f of x dx. We've got that rule. So this guy's good to go. But what about the h of x? It's also got to be -1 to 4. But when we look at this guy, again, when you look, you go from -1 to 1. That doesn't match the integral that I've been asked to solve. I've got the -1 part, but I don't have the +1 part. And so again, just like on the first 2 integrals on the bottom one, we do not have enough information to solve this out. So pay attention. It's not just a guaranteed to have a solution each time you're given an option like this. Okay, this is one of the bounded ones, the maximum inequality ones. And so the rules that we want to follow for this guy, if you look back on that very first sheet, is that if we've got the minimum of f, whatever that minimum is, times b minus a, then it's going to be less than or equal to the integral of f of x from a to b, which has to be less than or equal to the max of f times b minus a. All right, so these are the kind of the rules that we're working with on that. And we've got this integral right here, the square root of 1 plus cosine x dx from 0 to 1. We just want to show that it's less than 3/2. And we don't really have a way to solve this integral out right now, but we're just asked to show that it's less than. So here's what we're going to do. We're going to take our integral from 0 to 1, and we're going to look at it like this, cosine x dx. And we're just going to say that, hey, it's got to be less than the max value that this can be times b minus a. Well, b minus a is not too hard. That's going to be 1 minus 0. However, finding the max value for this guy can be tricky. So 1 plus cosine x. Well, ask yourself, what is the max value that the cosine of x can be? And the max value that the cosine will ever be, the max it will ever be, is just 1. So when you're looking at comparing these guys, then we're going to look for the square root of 2 times 1 minus 0, which is the square root of 2. So we want this integral from 0 to 1. We want this integral right here. From 0 to 1 of the square root of 1 plus cosine x dx. We just want to show that it's going to be less than 3/2. Well, when we use the max value, of the integral, okay, when we use that max value right there, the max it will ever be is the square root of 2. Okay, so the maximum of the function inside the integral times b minus a is going to be square root of 2. Well, square root of 2 is less than 3/2. And you can punch that in on your calculator. And when you do, if you punch it in and check it out, it's going to be 1.414 dot, 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 dot. And that's less than 3/2. So we have shown that this integral is less than 3/2 using some of the properties that we looked at the very first part of the notes. Okay, the mean value theorem. The average value, the mean value, mean and average is the same thing. If f is integrable on a to b, in other words, if we can have a function that we can take an integral of on the closed interval a to b, its average or its mean value on a to b is 1 over b minus a times the integral from a to b of f of x dx. It's not too bad of a guy. Just relax, take a deep breath, and look at this guy right here. Find the average value of the function on 0 to 3. Does f actually take on this value at some point in the given interval? So we're looking at 4 minus x squared dx. Okay, well, if we want the average value, then we're also going to look at 1 over 3 minus 0. Okay? And this is the shape that we're going to have. Well, we haven't really talked yet about how to solve out this integral right here by hand. We're going to learn. But what I want you to do right now is just plug this into your calculator under your function integral option, or as the book often refers to it as NINT, okay, numerical integer. And go ahead and plug that into your calculator real quick. Hit pause if you need to. And I'll tell you what you're going to end up with here in just a second. I'll let you pause it if you want. And so when you plug this in to your calculator, you're going to get 3. And so the average from 0 to 3 of 4 minus x squared is 1. Pretty cool, huh? So what we want to know is, does f actually take on this value? What does that mean? That means, does 4 minus x squared ever equal 1? That's the question. So then you just solve this guy out right here. So subtract 4 from both sides. Negative x squared equals negative 3. So x squared equals 3. And so what you end up with is x equals plus or minus the square root of 3. Okay, so when you solve it, this is what you get. Now, the interval that we're on goes from 0 to 3. So what we have to look at is which of these answers works. And so the answer to our question, where does the function f actually take on the value of 1, is when we're at the square root of 3. Okay? And so then the mean value theorem for definite integrals is going to be very, 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 very super duper similar. If f is continuous on a to b, then at some point c, 1 over b minus a times the integral from a to b of f of x dx is true for some specific function. Well, we just found that's what we just did in the previous problem, actually taking on the value of the average is what this guy is saying right here. So when you do the numerical integer and you multiply it by 1 over b minus a, you're getting a y value. This is a y value that represents the average. Okay, and so if I want to know what x value matches that, then I just set my equation equal to that y value right there. That's all there is to it. Don't let it be a hard thing. There's harder things to come, but just take your time and double check yourself and make sure that you're working it out right.